We have several different quantities we have to be able to describe in order to really do physics. We have to be able to describe how much stuff is present, okay? And that's what we call mass. Now, we use the SI system of units in science. I know you guys are all familiar with the American system, where we measure distances in feet, and we measure weight in pounds, and we measure time in seconds, minutes, hours. Well, we do have a different set of units for science, and you guys have been using these before. Mass, which is how much matter is in an object, is actually measured in kilograms. Okay? Now, there is no American equivalent to kilograms, at least not that you're familiar with. You know what it is?
It's a slug.
It's a slug. You ever heard of that before? Probably not. Not important, okay? So mass is not to be confused with weight. Mass is actually the amount of matter in an object, and it is measured in kilograms. The SI unit for kilogram is kg. That is 1 kilogram.
You can go pick one up. It's about 2 pounds.
It weighs about 2.2 pounds. It has a mass of 1 kilogram, and it doesn't matter where you take it, right? I take this to the moon, it has a mass of 1 kilogram, but it's not going to weigh 2.2 pounds anymore, because weight is a force. It's how much gravity's pulling on something. And that's different, okay? So mass is not weight. That's yeah, okay. Okay, so we have to be able to describe how much stuff was moving or isn't moving, as the case may be. We also have to describe how far it goes, okay? And to do that, we use length. And this is not a yardstick, okay? This is a meter stick. It's almost a yardstick, but it's 3 3/8 of an inch longer. Okay, the SI unit of length is a meter, and 1 meter is this far. Okay, it is a little bit more than a yard. If we had 100 meters, it's a little bit longer than your average football field. Okay, and you can see she's been putting up our labels for this. Length is measured in meters. It's a lowercase m. Mass is measured in kilograms. It's a lowercase k and a lowercase g. Okay. Now there is one more base unit that we need, and it's time. Okay. I don't know how to define time, the order of events that things occur in, and usually we're not interested in what time it is, right? I don't care that it's 1:30 in the afternoon. What I want to know is how long did an event last? What was the duration of an event? And so a lot of times we're going to talk about not t, but delta t, and delta means change in. So we want to know how long it took for something to happen, or maybe the time between events. Okay, so how long between start and end? And the unit for time is seconds. Okay, most of what we talk about in physics is going to happen over short durations of time, so we're going to be using seconds. Occasionally we'll have things in hours and minutes, and we'll have to be able to go between seconds, minutes, and hours. But since time is measured in seconds, we do use the unit, the symbol S, for time.
Okay, so at the beginning of this video you said that we just need 3 things to do physics to begin with: mass, length, and time. But I know in physics we're going to be talking about things like speed. I don't see speed up here. So
okay.
How can we take that into account?
Okay. Well, when we have things like speed, which is actually telling how far an object has gone in a given amount of time, you can see it's actually going to be a combination of these 2 units. So these are what we call our base units. These units are going to be combined to make other units called derived units. And you just had a perfect example. Speed. Speed is the derived unit, meters per second. Okay? And so there's actually a mathematical operation in that unit. It's a meter divided by a second. It's a distance divided by a duration of time. Okay? And that's a derived unit. That's a little bit different because now we're doing math already. Okay? A lot of times people are like, hey, is there math in science? Well, even to express basic units, we're using math. Okay? So this bar, this meters per second, that's a division bar. And so we can actually treat units like algebraic quantities. Okay? And it's very important, just like in algebra, I can't add x to y. I can add x to x if they match. I can't add meters to seconds, but I can divide them, right? I can multiply x and y. I can multiply and divide x and y, but I cannot add and subtract, okay? So one of the things we have to keep in mind is units have to match if we're going to do addition and subtraction with them, and for division and multiplication, if they do match, then we can do things like, you know, squared, cancel units, whatever. Okay, so these derived units that we're going to use, we're going to have derived units for speed, common example. Later we'll see acceleration, we're going to see force, we're going to see momentum, we're going to see all kinds of things. But we have to keep in mind that these base units are actually making up all those other units. Okay, so we can combine units with multiplication, division, and we have to have them matching for addition and subtraction.